Okay, so this is about drop or a designated release of payload. This is a proof of concept mechanical showcase of a different type of release mechanism that we designed here at UAH. So yes, be my guest, and it'll be passed around so everyone can get a look at it. This is a prototype of the device. So to start off, what is drop? So drop is a robust and reusable mechanical payload system that's used to drop from high altitude balloons. If you're looking for an alternative to something like the hot wire cut downs, this is what we've designed it for. What it utilizes is a consumer archery release trigger. And this is because these triggers can withstand a lot more force. They can withstand a lot more pressure on them. So we're able to load heavy payloads onto it. And we use the servo actuation to trigger the release. Some of the pros that we have for it is it can be triggered multiple times across one launch. It's able to take higher loads. So far, we found it to be more reliable than something like a hot wire cut down for a number of reasons. And one of the biggest pros for it, in my opinion, is the fact that it can do instantaneous activation. There's a little bit of timing unpredictability with some of the hot wire cut downs that we've seen. You know, you can't necessarily know exactly down to the second of when it'll actually cut through the wire. By using this servo actuated archery trigger release method, you're able to send it a command and it'll immediately cut down. Now, this is a proof of concept. So right now our current design is bulkier and a bit heavier than the nichrome cut downs. But right now, a lot of it's made out of 3D printed material. And we're looking at a lot of different ways of mass saving, as well as making it into a more compact size. It's currently configured at this moment to do packet recording, pressure data, and live communications. It also can be configured to look at GPS data, humidity data, IMU data. And this is really useful because there's a number of different ways that we can gate this to be triggered upon separate events. And you'll see like the main intended setup for it is your balloon system at the top, the drop device located directly below it, the parachute, and then the payload train underneath it. And just like with other cut down methods, from that, you're able to suspend your payload line, and the only material that is lost after using this drop method is the balloon and any in-between line. Some of the applications that we've been looking at before. There's 3 different methods currently defined to be able to signal drop. You're probably familiar with all of them. Target altitudes. This goes hand in hand, especially with a lot of Todd's work, where we're able to look at, you know, different launch heights and different and track basically, you know, if the payload reaches a certain height, where it's going to land following that. And we've been able to get fairly accurate results with where it's going to land based on being able to target very specific altitudes. At one point, they were close enough that we almost caught it as it was falling down, which was pretty awesome. You can also geofence it. This is very applicable if you're next to any you know, restricted airspaces that you can't cross over into. And we also have a live command system set up. We utilize an XB900 HP on the drop device to be able to communicate with it from a ground station, and via that command it to drop at specific heights. So as a main demonstration of its function, I'll load in a little bit. The main purpose is for a balloon release, which you'll see here. really effective with the release of the payload train from the balloon. And on top of this, we've also inverted it in the past where it releases payloads, where we've hooked up 2 drops in a row, one to release from a payload line and one to release a specific payload at a target altitude. It's a really nice, quick and dirty method of if you need to send something up and you need to drop it at a certain height, maybe you haven't had the time to design a release system or your payload to be dropped at this specific height in advance. You can just throw it on the line and it'll drop at the specific height. On top of that, one of the things that we were slightly concerned about was whether or not the servo was going to potentially encounter any errors with the vibrations during launch. For that, we've got a very simple solution. Just shield it from the wind with a little container. Very, very effective. And basically by also triggering the servo to be active during the flight and to hold its position. So the servo is powered throughout the flight. It's able to electrically not have any interference or have any vibrations potentially accidentally trigger the device in advance. Like I said, the other method that you can do it is you can reverse the configuration of it to allow for a target payload to be dropped at a specific height. So I'd like to do a bit of a demonstration of the payload. Todd, would you like to come up here and help me?
Sure.
I'm gonna start by turning off the servo.
Let me turn the lights on for a second.
Okay, that's all right.
I'm gonna do it, and you're gonna want to do the. Ready?
Thank you, Shivani.
There you go. Woo! It's very loud, I won't lie. Here, I'll try to not blind anybody. Can you hold it?
I got
it. Get at the ground station.
We got our little test subject astronaut here.
I was gonna, if you drop the payload, I can catch it.
He's gonna catch it.
Okay, well, I thought you were gonna do it the other way, so,
Why would I drop the drop?
well, because that's what it is.
It can do either configuration,
It
thankfully.
can hold its own weight and drop itself.
That is
Yeah.
true. We could do that.
Yeah, so
Do I
yeah,
trust you?
I trust myself.
What is the weight of that unit?
So it's right now sitting between 1 kilogram and about 1.5 kilograms. That being said, we've already identified like numerous different ways
Yeah.
to bring down the mass on it.
A
A lot
Mackie
of
built
it.
it.
Yeah.
Yes.
A Mackie built it.
This, especially this deadbolt, we just found in the lab, so we could definitely get a later one. No, we just found that and just put it on, but it worked. Okay.
Okay, I'm ready. Okay, it's
Okay.
remote.
I can't necessarily showcase this to anyone on screen, but we're able to, transmit data directly from it to our ground stations. We're looking at altitude, and on the day, just, a simple press of the button.
Jump back up and grab the one.
So,
Having too much fun.
Can you do that again?
Yeah, but as far as what it can hold, it can
Give me,
hold
2
a
seconds.
line. There's a thicker line.
okay, I'm
Do
gonna,
that.
You can pull it. You want to pull you on it and let it let go you.
Are you sure?
okay, ready?
Ready?
3, 2, 1.
It's gonna get hurt.
Pretty easy.
We had one other question online, and it was, one was about the mass and size. I think everybody can see the size. The other was the cost of the components. What do you think?
Oh,
that's
yeah,
gonna be?
sure. I can actually go through that. I do have like a couple of, I want to talk about some of the flights that this has flown on real quick first. Our very first flight that we did was to check if, it worked. We had a proof of concept flight. We sent it up with an altitude cut down, went up to 7 kilometers, released, and it was a pretty successful flight through and through. Nothing of any particular note. You can see it wrapped for thermal protection there. This was during 2 months, we used it as our as both a cut down. This is live cut down that we did once, as well as a couple pre-programmed altitude cut downs. And we also did a payload release. We sent up a glider that was named Grease Lightning, a famous one. We sent it up. We were able to drop Grease Lightning separately and then also do our payload line, pretty successful. And then our final one, this is the video that y'all saw earlier. We were doing a packet test to see at different altitudes, you know, how long we can keep in contact with it. And if I'm quiet, you should be able to hear it beeping over and over again.
If there's 2 drops on there.
There, and it does that about every 10 seconds throughout the flight. As we flew it out to about 8 kilometers high, I believe, on this one, we saw an 80% packet success rate both ways. With the ground station, the 80% success rate was coming from the payload up there to the ground station, because we had a small little duck antenna attached to the XB. We were using a Yagi antenna from the ground, but we were getting 100% packet success rate from ground to payload. Yes.
That's a 900 megahertz XP.
Yes, 900
And
megahertz.
what power was it? The high or low power one?
We set it to highest TX. It was the highest transmitting power throughout the flight. We didn't experience any issues with power loss throughout it, so that was great. And it was up there for about an hour.
You rotate your Yagi antenna based on its altitude.
If
you keep it level, that's probably where your 80% came from. Also the angle in which it kind of. We were
So that
driving
was
in
an
the car.
yeah. We had a Yagi
Out the
antenna.
window.
It was interesting because we had two of the drop payloads up there. We had one that we were commanding to do the balloon release, and it had a target altitude cut down, very simple. And then we had the other one hooked up to my ground station. Both of them had Yagi XBs, and it was running a packet test through XCPU the whole time, which is where we were getting our data from.
Yeah, I was just wondering if that angle, if you angled it up toward where the balloon was, you might have a higher success rate.
Oh, that's probably 100% true. That being said, driving in the car doesn't really allow for great line of sight control or anything.
You guys don't want to stand out the glass window on top of the roof.
I'll say we tried to catch this one.
That's
So
it.
it was a little avoiding people out the sunroof.
Yeah.
With the
It's kind of hard when you're hanging on.
Yeah. that 80% is probably because
Yeah.
we weren't looking at it 20% of the time.
Just trying to hang up.
But you know, nobody died, which is, I would say, a success. I think that's.
We covered this.
This time, nobody died.
But yeah, and just across the board, we really like this drop mechanism in comparison to the hot wire cut downs. Throughout the years, we've used them in the club quite a few times. We've experienced some unreliability in their methods, but also, you know, you have to replace the wire each time, and they're not the most inexpensive option in the world. This is, at least in our opinion, it has a lot more reusability into it. It has a lot more configuration that we can do with it. And I don't know if anyone saw in these lines, these balloons were under quite a bit of tension. Some of these days were fairly windy. And we didn't have any issues with the payload line breaking, and we were a lot less concerned, I would say, throughout the day because we had this instead.
I want to make one comment. This line here, what you're seeing in this picture, you see these people in the field, and we're spooling out the line. We're not letting go of it. But at this time, there was a point in which we held the flight for 10, 15 minutes as people were making adjustments, and we were holding this line in mid-October in high wind. And so I was probably wrapped around, that's me, trying to hold this thing. And this is, again, a 1,600 gram balloon, full tank of helium's in that thing. It is a big balloon. And it is pulling really, really, really hard. And this device is right there.
Wow.
And at any moment it could let go of that entire balloon. But as we held for up to 15 minutes, it's not letting go at all.
So do you have dynamic measurements of, you know?
Oh, what different forces it can take?
Yeah,
No.
okay,
It just hasn't given out on us yet.
okay, that's good enough.
What precautions, if any, do you take to prevent that from interfering with the parachute actors?
So, we do have it in this, for the most part, it keeps it from getting wrapped around, anything. Yeah, go ahead.
So this up here, this is what I came up with. You can do multiple things. See how the parachute is tied to the line?
Right.
So that kind of keeps it away. So when it falls, now the downside of setting it up like this is when you're flying up, your parachute's upside down.
Right.
So you're creating drag with your line as it goes up. That reduces the ascent rate by only really like 0.8 meters per second. So you can compensate by filling it up. We have done it before where we have flown it above it. The key is just making your parachute farther away from the drop. Because the goal is to get the parachute to come up, right? With the drop to fall below it. So it doesn't plummet directly on the parachute.
Right.
Again, like tanks.
And we pipe stuff above the lines. When stuff falls, that parachute wants to open. Having a draped line go around it and kind of push on one side really doesn't stop the parachute from doing its job.
Just adds durability.
It just pinches maybe a part of it, makes it come in, but really the parachute opens.
Is your parachute, your payload attached closer to the parachute, or is your payload attached to the drop pod?
In this picture or in all examples?
Well, in general, I'm concerned that if your payload was attached to the drop and the parachute's kind of luffing around here, would it wrap around the line and get tangled?
We've tied in like this T kind of configuration, we call it. It tees off from the line of the parachute, and we haven't had it wrapped. That is possible, but
So what's really nice about this is, remember, your balloon's going with the mean wind. So your parachute typically is always never with the line because it's blowing in the wind,
Okay.
right? So it's never, I mean, we've flown it like this a lot. We've never seen it tangled up.
Great.
That's the one thing about having a parachute that's larger. It always wants to kind of be away from the line when it's dangling. Because you're moving with the wind, and that typically can be blown away from the line.
and these are like 7-foot chutes. These are not small chutes, these are big chutes.
We typically fly bigger stuff.
Yeah, and this is a payload line that's probably 12-pound
Yeah.
load.
In this example, I just want to be clear, this is for a program where we're teaching students, basic engineering principles, mostly freshmen. We deployed these gliders. I think we cut down really low. We're not dropping these gliders at like 20 kilometers. So this was, we drop them in a field that's like, what were it, 100 meters up?
It was a 700 meters.
Yeah.
cut down.
Yeah, so they land in the same field we launched.
Yeah, so for this example, the students had built like these gliders and these deployable payloads, and they were responsible for cutting down from the line, but we needed some sort of master cut down.
Right.
Assuming that they didn't get off of
Yeah.
our line, we could take the whole thing down. And that's what this, it wasn't built specifically for this, but we used it for it. And of course, somebody's glider needed to get reconfigured at the last moment when the line was in the air, so.
Is that an RC crash I see about to happen
They're not
It's attached to the line.
on the right side? Looks like an RC airplane about to crash. I know.
It looks like it.
but it's hanging on the tail there.
Okay.
I was just wondering, the exact purpose of the LED. I commend you for having such an awesome looking LED, but I was wondering if that could be utilized for like a night drop, and if it's programmable to say, let's come on at 5,000 feet and below, or.
It absolutely could do that.
Okay.
We use it just to find it really quickly in the field. But
And a state indicator, like, hey, I'm in my flight state, or I'm in error state, because of course, if the barometer is missing for pressure altitude. You want to boot it up without the, I don't know if you can take it out, there's an error state, and it lets you know that it's not happy, it's in an error state. So that's its like
Mhm.
flight state right now.
But it would absolutely be able to do anything attached with that. Actually, the code for that would be extremely easy.
Does it just flash differently if it's in,
The buzzer and the light flash with error codes.
oh,
Yes.
buzzers?
So the buzzer that you heard, like, hey, I'm turning on,
Oh,
but also
okay.
when it actuates, it beeps. When it actuates to let you know it's about to drop something.
Okay.
And it will flash accordingly, so state indicator.
We've actually used this to drop stuff on drones to actually test other payloads. So they do a competition where they make these little, they're called CanSats. And we used it, we put it on a big hexacopter. We have a big drone department here, and we actually used it to drop and test their parachutes on the drone.
And that was another time we used live commands, because we were gauging as we went.
Does it sense burst and release? Or if the balloon bursts, does it just come down with everything else?
So, yeah, it's able to track altitude, so it would, if it notices that it was falling without the servo mechanism having yet actuated, it could absolutely release the payload.
Can or does?
Programmable,
Programmable.
Okay, good.
In fact, we've done stuff like that for CanSat, so
You
actually.
really get rid of the latex. You really don't want to bring it back down.
No.
Does it grip onto a ring or does it grip onto a loop of line?
So it can do either.
We've
What
done
have you
those.
found is
Yes.
the
We
best?
like the ring just because we know that it's a clean interface and like the loop won't close itself up to tighten too much. So like a key ring is, I think in all these, some of those, it is a key ring. So we use maybe a key ring, but you could of course make a loop in line. And that's what we just did to demonstrate this loop of line.
Did you touch on cost?
Oh, yes, okay, so across the board, if you're looking at each individual component, this is what? Let's see.
So the archery release trigger, I think was $20.
Yes,
That was a pretty cheap one. You can get really nice ones. That's a cheap one. And as far as the COTS components, I mean, it's a CNC microcontroller, $30.
I think it's about 150. If I think your Sarah's presentation actually lists this as $150 in total components. That's for the PCB, the batteries, the buzzer, everything that's currently on it. Obviously, you can add more sensors to it. As an I2C line attached to it, so it's not very difficult to add extra sensors to it. Dimensions of the device. That one I don't know. I didn't do the mechanical design. I'm software.
I'll get her example. But no, it's about
Size
five,
of your hand.
the size of your hand. It fits in the palm of your hand. Float. Size of a phone 40 years ago.
Size of per cell phone.
Drop device like that was such a big topic at GPSL for years back in the early 20s, like before you guys were born.
Is there a portion of the gray part is 3D printed, correct?
Yeah,
Is
yeah.
that basic PLA or is it something different?
So it's just basic PLA, although we've actually been looking at doing composites to mount it as well, because this is obviously more bulky, kind of heavy, and there's definitely different options to make this lighter.
We have a lot of people who like composites in the club, custom fiberglass composites, wood fiberglass composites, a lot of the stuff like that is becoming popular in our group.